common, it's going to be pretty much repairs today. Especially guys that fix a lot of cuckoo clocks, and a lot of people that collect cuckoo clocks. The biggest thing is you can fix them mechanically, but the outsides are usually busted up. 100 years worth of wear of anything that's worthwhile collecting, it's going to show signs of real abuse. 90% of the cuckoo clocks in the world will come off the wall at least one time. What I'm going to try to show is some of the most common things that you come across if you are collecting or repairing cuckoo clocks, in that if a clock had come off the wall, the biggest problem that you're going to face is repairing someone else's inept attempt at repairing something where there'll be cross-veining that's not lining up, different stratas that they have, different heights where they didn't use a clamp, didn't clamp it to something flush, putting on things where something would be sheared off, the ends of leaves. A real common problem with cuckoo clocks would be shearing off the horns. That would be a real big thing because they come off the wall, and the way the grain is oriented, it's always up and down this way, and the first thing to shear off, they're really soft. I always repair things. The reason that you would repair things is, number one, sentimental, and number two, for profit. And that usually relates to one relates to the other, in that I'm a shop owner, and Grandma's cuckoo clock that you may think is worth nothing is $1 million clock to that, and a lot of guys know that I used to have an apprentice and let him go just for that reason. And that the gal came to me with what would have been probably a 1950s novelty clock, and bought in Germany sometime mid-50s or early 50s, just post-war, for about $1, $1.50. That clock was worth $1 million. So the most common things that people do wrong is just get out the blue bottle and try not to do it the right way first thing. Most common thing you'll see is the cuckoo clock face coming off the wall. It's got one very prominent low point, and it's always usually the center leaf. So that center leaf will be sheared right out. Generally, it'll split the carving into 3 pieces. And what they'll do is they'll throw it on the table, and then they'll try to get some glue in between and just kind of push it together. Well, I've seen plenty of guys make the attempt of putting it back together again. They won't check it for alignment on the back to have a semi-smooth surface. They'll get it all recarved, put it on there, put the nail through it, and crack it right in half. And that's never seems happy done. So the first thing that you would actually do is determine whether or not it's worth fixing to you. I mean, if it is, go ahead and do it. But showing that it takes very, very rudimentary carving tools to even accomplish something very well done on a cuckoo clock, because most of it, since about 1940, just post-war, would have been 90% of the clocks coming out of Germany were machine carved anyway. So what you're going to try to do is emulate that and replicate that surface. It's a very, very easy surface, and you can get away with pretty much 3 chisels that will do that. If anybody do any carving besides Kelsey, if they're looking for chisels, what you're doing is you're always looking at 2 different numbers on a chisel. First number on a chisel will either give you its profile or its definite name in number code. When it starts out with a single digit, it will be a round. It will give you anywhere of a grading from a 1 circle down to a 28 circle. And that tells you the tightness of the diameter of the circle. The second number is always followed by how many millimeter wide that plate is. Get into profile chisels, which everybody, if they're going to try this, they're going to need 1 profile chisel, which is going to be like a V groove, a tight V groove. It can be a 90, it can be a fluting chisel, it can be anything that somebody really gets comfortable making the cuts that they have to make. And guys will, I know wood carvers that have 2,000 chisels. They mainly rely on 6 or 8 different chisels. They may have ones over here, but they very rarely use it. Anybody that's a part-time wood carver will go ahead and collect chisels, and there are guys that just simply collect chisels and will never label them to wood. But these are the ones that you can actually, I could actually recarve this piece from raw stock with every one of these chisels here, probably only half of those. So it's very rudimentary setup that you need for this. But the things that you need to remember are the clamping. And that's the biggest part of getting something right to actually go ahead and make it worthwhile repairing. The biggest thing is most people just try to take a clamp and they'll make a patch and they'll try to clamp it together. Inherently, you're always going to get one of these. and you're not gonna get a real tight bond. So before I cut out any patch to pattern, you have to make a piece that is your thickness. Here, we're just working with basswood, and 99% of the cuckoo clocks that you're gonna come across are made of basswood. So what I always do is I take a piece, cut it, and I always leave 20% more. The part that's broken, you're gonna have to take off some more, because if there's any kind of an irregular edge, you'll never get a groove onto it. So what I always do, a good surface sander, a belt sander, a disc sander, anything that will have one definite plane against a 90-degree, take that and sand that absolutely smooth with one push to it in, so that you don't want to gain any heat, because the more heat that you put to this, that surface will actually, that you're sanding will actually tighten up a bit and make the glue rate, absorption rate a little bit less, and you won't get as great of a bond. So I always leave about 20% more material than what your thickest piece is that you're going to be carving. And that allows you in the first few strokes to get what the grain is going to do for you, because you have to work with the grain, or it will shear your grain piece off just as fast as what the other is. So what I'm always doing and showing is that you get those pieces absolutely straight. If there's one on the other side, great. If not, what I would actually do is cut another piece of basswood, similar material, take that leaf, lay it on top of there, get it so that it fits in there directly. Then while the piece is all set up, we would take this, clamp this whole piece down to a table, clamp this piece down to a table, clamp this piece down to a table, and what I mean by that is rubber-based clamps like this will give enough that you can then take a bar clamp or even a big Jacobson clamp. I have some of these that are 14 to 16 inches, and you can actually spread them and stand them so that you can compress this in them. You're not trying to do everything floating, because inherently you won't get a good glue joint to it. Something will be out of place, something will be leaning and twisting that way. So something like this I would take, clamp it down like this, and then each and every one of these pieces then would be clamped, and then use a bar clamp across, and then squeeze it all together again. And you have to sit and be patient for at least 24 hours. 36 hours is usually the minimum. I glue something before I put a chisel to it, because otherwise you look like a real fool once you start carving and that piece falls right off again. Or when you get it 80% done, there's no way you're going to be able to effectively clamp it back again without destroying what you've already carved and configured. So that is the biggest thing, is patience with it, because you have to wait and let that glue dry. The best things for gluing anything of this size, when you've got a full regular bond that you can get, are any of the wood glues, the white glues or the yellow wood-based glues that you want. That is the best, you're going to get the best adhesion for that. Things where you're doing what I would call a micro patch or a small patch. I don't know how many of these people who looked at this, in that about 75% of these acanthus leaves were broken off. And what they are then is I'm showing how to fine patch on these, where some of these are only about 3/32 of an inch thick, and they're cantilevered over, so putting a patch on that is about the most difficult patching you can do. In that case, I'm not using wood glues. I'm using acrylic xylenes, fast drying glues that way, transparent glues. And what I'm doing that way is I will coat that piece that I've just preliminarily made for that with that glue and let it set for 24 hours, because the adhesion rate between the glue itself and itself is great, and the bond is wonderful. So you can actually get that piece to be stable on there while you're doing this. And what I do on any carving that's cantilevered or very, very thin with a cross orientation of the grain, where all of these shells that are carved, the grain goes this way. Inherently, that was a design structure problem, but you're never going to get away from it on wood. What I do then is I carve my top piece, leave it about 20% thicker, get the back contoured about the same, then it's adhered with the glue. Then I'll take a small gouge and go ahead and carve in from the back a disorienting piece of grain work. And so that will, I'll scoop that in there. If I try to go double of what the patch is, if one of these acanthus patches were down here across the seam, I will try to get that patch to go all the way from the extreme tip, try to get as much of the webbing as possible in here, and carry it all the way down to as far down into that carving as possible. And that way, it's got enough to carry me putting pressure against it with the chisel to finish it. Also then, cuckoo clocks and a lot of carved clocks are up in a hotter atmosphere than most of the rest of the room. So they're real subjective to expansion and contraction of the air changing over. Well, if you're having two pieces just end butt like that, chances are in a year it's going to expand and contract enough that it's going to fall right off. If you don't reorient the piece on the back side of it, you might as well not do the patch. A patch like that now, it takes a very, very long time. It takes me about an hour to an hour and a half to do a patch like that from start to finish. You're actually making two separate pieces, laminating them together at the end, pressing it, and then to carve it. So it's a lot of little minutes adding up to one project. So this one here, I bet you right now I'm replacing most of those somewhere around 30 to 35 hours. So that's about an hour and 15 minutes for each one of those patches or so. So it's worthwhile, yes, because it's a very, very rare clock. But then again, if this was Grandma's clock and that's the only thing you have from Grandma, it's also a very rare clock. So the problem I'm going to have here a little bit is because my carving benches are usually right here. And my vision is always set to that. But if anybody wanted to come around, I can show you what I'm going to be doing. But some of the other things that somebody had asked me about the chemistry and patching. Once you make the patch, finishing is the hard part because you're obscuring a lot of the blemishes you can leave behind by transitioning from one old piece to a new piece. And the chemistry is what gives most people afterwards the biggest part because they're trying to patch an unknown product with something that they know nothing about. Our chemistry tells us that most of the clocks that we knew as being stained are the older cuckoo clocks. This is something from right around the turn of the century to about 1920. They probably used the same chemistry and everything. What they knew as stains, we knew as latex stains. That was just their paints. We had access to a lot of the leads, the heavier inert particles that we added to paint to give it elasticity and things like that. We changed our chemistry in the United States to be a little more environmentally safe. We went back to latex stains. It was about 30 years ago. And ironically, the chemistry is identical and it matches perfectly and it blends perfectly so that to the point where you can actually sand parts and make sure in a guaranteed way that you can match that original color pattern again. And then with our application of modern urethanes and sprays where you've got 3 different hues of satin to gloss to matte, you can pretty much replicate anything that would have been a finish. The one problem with that is you're not always taking all the dirt off of this. And when I do my conservation work, what this is for chemistry is I will take in 7 different stratas, starting with petroleum distillates, to then ammonia-based distillates, to then water-based distillates, and I will clean this clock with cotton swabs or gun cleaning patches. And when I'm trying to hide something and make something absolutely perfect, I will clean this clock preliminarily with each and every one of those steps, taking those patches or swabs and keeping them in a vial. After I'm finished with this clock, I will go ahead, clean from time to time to make sure that the area that I'm patching is prepped. But I will then, after those pieces are on, stain to what I think is the closest match, reverse the chemistry, reconstitute those pieces of grime that I took off, put them back in the same distillate again, and re-wipe them onto the surface and let them evaporate. So that even if you tested the chemistry, it would all come out the same age. It's the same gunk, barring a little bit of the evaporatives left of the final distillates that I used to reapply, and that's it. Otherwise, you can't tell that the chemistry is different, and in that, the look is going to be the exact same. Because a lot of these things, patina, for instance, on a lot of the iron clocks, bronze clocks, a lot of that patina comes from hands. And a lot of this, you cannot replicate the color of 100 years of hands on it. And someone touching it, and someone rubbing it with their oils, and then those oils in your hands going rancid and hardening, and then again, acting like a wax. So those are all the things that you need to take and put right back on to make it look like it's always been there. So, I'm not sure what you guys are going to be able to see. What I was talking about is, you've seen some of that. This is the final result. This is a German automaton. This one was crashed to the floor some 50 years ago. I dare anybody to find the patch, and I will even give you a hint that his complete elbow was ripped right off. And that's the way you have to do it, because this is about a $9,000 to $12,000 machine right here. And well worth it. I think this gentleman, besides the movement in here, he's got about $1,000 in restoration, and he's still got a little bit yet to do, but it's going to be finished. Well, again, now the difference in some of this is machine carving as opposed to hand carving, and if you're going to identify a clock, if you're interested in buying a clock and you want to identify it on its age, some of the telltale things that you can look for is the way that the piece was roughed out. If you look at most of them, anywhere from 1900 on up, you'll see definite saw marks because they were always roughed off with a bandsaw or a coping saw. Most of the higher end clocks, yes, they were cut out with a coping saw, never had a bandsaw touch them, but it's still the same looking saw marks. Before that, you'll see where they were roughed out with a bow saw, but never brought close to margin, never brought close to the line. And you can tell every time in that there's 1,000 little relief cuts per square inch on that, in that they had to bring it to configuration before they started cutting the front. They had to get their definite shape to the back so that they weren't tearing off big strands of lumber and affecting the finished garment. So, if you look at a clock, you see where it was relieved, and these are always called relief cuts to go ahead and change thickness for profile. If you see that as just one big plane that comes across, chances are it was just that, a big cutter that came through, just rough shaped everything to angle, and then it was finished off with probably 7 more CNC machines or patterned machines that would bring it out to about 95%, and there was very, very little handwork. This was a Hubert Hare clock, vintage 1970, somewhere around that. The only thing that woodcarver would have done to this is he would have finished up some of the very small, short little veins in the leaves. He wouldn't have done any of this fluting here, except for in the very tight recesses here. That's the only thing that would have been done with a chisel on this clock. This one here, again from about 1900 or so, this is like a cheater clock. They already had ball cutting technology around for about 30 to 40 years. The English were using it for, probably some 50 years in old, either water-driven or kinetically driven some way, but they were using 1-inch ball cutters with 3 cutter faces, and they were probably only turning at 800 RPM. So it was a very coarse roughing out of it. They would go to about a 1/2-inch ball cutter and finish up some of the profiles, but then about 60% of it was done by machine, about 40% of it was done by hand. All of the finishing on edges and things like that. But the basic shape and the contours for the different X, Y, and Z axes were all taken in pretty much that way for heights and thicknesses. Then the carver came in and did all the rest of the recesses and the relieving on it. This, on the other hand, you can feel that every piece of it, there was no way that they could use a ball cutter on this. You can feel every recess from behind has got a different chisel mark. And you were using something like a very small profile gouge, something like this, or something like this, just chipping it out one piece at a time from the back, and it was a very, very slow process. A man probably had about 60 hours or less of carving into this clock at the time when he was done. Hubert Hare machine like that was probably total time is about 3.5 minutes on the machine table freeze. That's about it. So, if anybody wants to kind of gather around, I can try to show you what's going on here. It's pretty much the only way you're going to see anything. So, mallets, carving chisels. Usually everybody uses a lot of mallets for every stroke. I don't. I've practiced control my whole life, and in that, if you're using a mallet, it's probably usually for the last finest carving, especially because I'm getting arthritic now and a little old and shaky. Everybody does, I hope. But it's for carving the finest because it's a definite amount of pressure applied to it at a stop. And that's the only way you can really come out with that. hand detailing then is always done with just the cheapest of little tools that I've always made. Hardened steel that I'll flatten and reharden again, grind it to whatever profile I'll need. And that's usually the extent of what I'm using for any kind of delicate work. It's just things that I've had that I know will fit that job and use it. So I'm going to clamp this one up if anybody wants to come on up closer if they can't see you. Anybody else that way can just stand and gather. Be able to see what I'm talking about. This one I actually had to take a very nice piece and break it into a mess. So what I've got here is I'm trying to show the most common things you're going to come across with repairing a cuckoo clock. You're going to see things that are glued at different heights and they're very unattractive and they'll have raw wood showing. It'll just absolutely look terrible. It's what you're going to do now is you're going to be removing some of the original material, but you're going to be doing it in a way that this is going to be refinished anyway. This chemistry is really easy to match, so you're just under the premise you're going to refinish the whole piece. So this is what's going to be hard for me is, like I say, I'm up here, so I'll work this way. On something here where it would have been bent, busted, and then somebody has got maybe a 1/16 of an inch where that's overlapping. Taking a mild gouge, which would be, a gouge is usually something for taking off the primary layers, but I always call anything that's around it is a gouge because I would never use that as a finish chisel on the top. So what you would do is work out from a leaf that would be a definite, and you're going to take off what will fall off that piece first. And you're going to get it down to a strata where you won't see a crack anymore. And then 90% of your chisel work will be working from the interior out. So we know the grain always goes this way, and you're going to be working from inside out. And you're going to be bringing these pieces back together again. And you can, the crack will be a little more apparent then, and then you'll see how to hide that with finishes.
Is that one soft or
Yes.
sharp?
Both, but cuckoo clocks are made out of basswood, which is a very, very low fiber count, very soft, but it's a very straight grain so that you're not getting the tear-outs that you normally would get with any of the hardwoods. You first get the field, and then now that at least you've got no separation in there, there's no big gap to fill in, and then you work to even it out. That you're actually going to be able to hide in finish. But before you go any further, the veining is really what hides most of the repair work. In that then you can cut the veins next to what's already existing. Normally I have a plywood turntable and the turn and I just use one clamp and it's always fastened to that. And then carry the veins right back through that crack, overlap that crack. And when you stain that then, you don't really want to use any sandpaper until you're done with absolutely using your chisels. Because otherwise you trap a grain of sand in there, you'll cause an edge into your chisel and you'll damage it and you'll travel different ways. bird there. And with very, very light sanding, you can see the crack now, but that's actually what you're seeing is the glue line. And when you're finished with that and stain it, it will take on the same hue as the rest of the veins.
That came off of there, why didn't it go flat when you?
What's that?
It came off of there, right? Why didn't it flatten when you glued it together? You said
Oh, I
it
put this,
up.
yes, I did that, because most people don't use a clamp and keep it together. That's why I was just trying to show how to fix something that somebody went ahead and glued in
And glued
and
it,
did an
okay.
inferior job of repairing it. Same thing would be on top here. This happens quite a bit. When this whole thing splits in half, they'll do this, where the veins won't line up, it'll be off-centered and things like that. This, I would take, resand this edge on a stationary sander, and then this I would carve. Carve it back this way. And then I would make these veins. Tape doesn't allow for great clamping. And I would increase the size of these veins up top and bring them back together.
Bill, do you feel more comfortable doing those kind of changes to like a lesser quality clock?
I don't,
To make it
that's,
look good, you know? like
Yeah, that's all
versus
you're
like
doing,
Something
it's-
like that, you wouldn't change the design, would you?
no, I really
You-
wouldn't.
you
That's going back to absolutely as close as you can to original. This is modifying it to look good again.
Right, okay.
That's all.
Mhm.
You're just trying to do away with the half-assed repair. Pardon me, there's no other way of putting it.
If a cuckoo clock is from 1860, would it have to be hand chiseled?
Not always.
No.
Well, 1860, yes.
1860.
Hubert Hare started employing rotary cutters for roughing out in 1870s, 1871, 1872. They actually had a water-driven replicating cutter. What they had, it was a rudimentary arm that came down that was a follower arm that the man himself replicating a pattern, and it would only do one duplicate at a time. Then, in fact, the English were using in the 1870s and 1860s even, three-head cutters, where he could actually, and it came from the furniture industry, actually using Queen Anne legs and things like that. They found a way of doing that, so they knew a ball cutter could follow in straight lines, and they would do that. Hubert Hare started employing them in about 1870 to 1872. I think that they were the only ones up until about 1890. Anton Schneider, which is now the longest run, and it wasn't Hubert Hare, I'm sorry, George Hare, the predecessor to Hubert Hare Clock Company, was using ball cutters and rotary cutters. Anton Schneider then, when they built their new factory in 1890, they employed some of the duplicating cutters, and that was the first time they ever used any duplicating machines. So, 1860, yes, it would be probably all hand carved. I'm not sure what they had for technology, and there could be something that somebody roughed out something with, but other than that, not really. So, any questions so far? Cool. Those are just all handmade. These were,
Who made those?
yeah, I just make the handles, but these were actually an old tool and die man that I knew years ago. These were just things that he would make over the years, and then when he was done with them, toss them into his toolbox. And I just got a whole pile of all different kinds of configurations. He would use them 1 or 2 times and throw them away. He wouldn't need them anymore. But those are the ones, bet you I have 10 dozen of them. Those are the ones I use all the time. This here, I was trying to show you on the gluing. Surface area is very, very, very important for making patches stick. This is, like I said, this is a real common problem where these horns break off. So again, cutting out square patches or rectangular patches so that you can always put pressure in. But the thing I do to make it go, you've got a blind pattern. Most of them, either they have they've got a blinding pattern is what I was trying to say. In that most of them have a leaf covering this, but all of them, if they have the crossbar branches, they go ahead and they have this crossing, you might as well hide the repair right in that. In that you saw to it, you're gonna be taking your veining tool and then finishing it up on that anyway. Some of the other things, just bringing back these to height, again, are very, very easy steps with chisels. I always try to find out where my heights are gonna meet first with a semi-flat chisel. Where I'm gonna have to take out to what. And that just saves you from taking a big chip into the other piece. Oops. Always working outward. The deeper you get into a profile, you want to dish it out, the more radius you need and a shorter blade. I'll get the edge within about 10% there. I'll switch to a profile. And this is just most people look, this was a turning chisel at one time, a turning gouge. And again, showing that they don't really even make a chisel like this for a carving chisel. So this is something, if you've seen any of my big woodland clocks and things, this is what I ground then, because this is done without a mallet for carving, but I have to push through 3/4 to 1.5 inch oak to get what would be the bark on a tree. And each one of the trees have about 500,000 chisel strokes in them, and tapping like this would just take too long. So these are things that I have to do because I have to push on them and really give to it. Vein would be just continue that vein back up, and that's about it. Then after you were done profiling the whole thing, then it would go ahead and get sanded one last finish time, and usually just with 220 sandpaper, and then the finish to it.
How did you do the outside? Was that chiseled away too?
No, this is, again, it would have been chiseled if you've seen any of the relief cuts like this. That's how they laid it out. This is always bandsawed out, we'll use coping saw.
Now, you look like you, obviously, when you ground off or chiseled off your top, your excess wood,
Mhm.
you lost your profile line. Do you reapply that to find if you have an exact profile, or is this as close to?
Just as close as your interpretation, you know that if it's swept up, it's gonna continue to sweep up to a
So
certain point.
it's more of a generalized?
Yeah, that's all they really were. That's all they were. There is no definite contour to grape leaf. All depends on where you're looking at it from.
And it is what it is, and however
It
you
is.
think it looks
Right.
good, and that's where.
Right, it's not like something here where you know every one of these acanthus leaves went the same way.
Sure.
So that's all you're doing. Any other questions? Oh, cool.
Are you on the History Channel?
Don't think so.
Yeah, right.
Could have been.
Should be, right?
As soon as the film's developed, we'll be on there.
Right. Very cool, very good.
Okay.
Thank you very much.
How
You're
would you
welcome.
glue something that wasn't even on the back of the clamp
What's that?
down? How would you glue something that wasn't even? I mean,
Even on the back?
Yeah, if I didn't wanna go through this carving or anything.
Well, then you would, what I would do, and the way I always do this
These
is,
on the back aren't, they're not.
right, and that's why I say, what I always do, and clamping is the absolute biggest thing. Start on a very flat surface, put a piece of wax paper down. That way you never have to worry about it sticking to anything. And the first thing you're doing is making sure that the pieces are tight to the tabletop. This was always, like I said, this happened where somebody just put some glue in there, threw it together like this and left it sit on the kitchen table. It'll be dry tomorrow morning, we'll put it back on. kind of thing. But this, what you're doing is if, this was actually sheared off here, and you can see where I fixed it, where it doesn't need any more, you can't even see it that way. But this center leaf was sheared right out of here, here, and here. One I fixed the right way, one I fixed the wrong way. So I would start out here, I clamp this to the table. Then if this was broken into 3 pieces, I would already have this patch where it was all ready to be glued onto. That would be flat, so I can grab it with a clamp. Then again, I would take another piece off of my block, cut a piece that would fit around what was ever there, and squeeze it together. But always keeping the patch pieces clamped to the table. I would have a clamp on here, being held down, clamp on here, and then the clamp this way. But always being held down to this plane first. Because anything that's left, and if it doesn't fit together that way, say there's chips and strands that are inside interior pieces, if they're a problem because they're a strand and they're holding up that piece going back together again, it's best to take it out. Then I take a knife and I'll go into that piece, and I'll take out where the fiber is connected yet and take it out, because it's gonna be more of a detriment putting it back together than it's gonna have value. So,
On those side pieces there, did you ever use extra pins in there to hold them in place?
once in a while, but usually you don't wanna take the chance of having it in there and then hurting the rest of the carving, because if it would shear off again for some reason, it's gonna destroy more of the carving.
Okay, so what do you use for glue then?
Then I'm using wood glues, just carpenter-based wood glues and things like that, or unless I'm doing real small micro patches like this, I'm using acrylics, I have been glues and things. And then I'm prepping the surface in a way, you're taking a surface that's super porous and using glue that's for a non-porous surface at all. So what you're doing is prepping the wood itself with that same kind of a glue, letting it dry, finishing it smooth, and then the adhesion rate from that glue to itself is great. And you're using a light chemistry that way.
You don't have a problem with those yours breaking off or falling off?
No, that's the whole idea with reorienting that grain from behind with another piece.
Okay.
On some of the very thin Cuckoo Clock pieces, I've got a couple of them, the little tiny Swiss stack plate Cuckoo Clocks, and those were just a faceplate carving that's no more than maybe 2.5 to 3 inches wide by about 4 inches tall. And the material they start out with is less than 1/4 of an inch thick. That's their thickest part on it. To hold something like that back together again, I'll take a piece of basswood, go down to a 32nd of an inch shaved veneer, glue that to the back.
Okay.
And then again, reorienting the grain. So that but I will always take that, because they're so small anyway, and I always buy my basswood stock in 12-inch by 16-foot lengths or so. I will take it and reorient the grain this way.
Thank you very much.
You're welcome.